What's going on, everyone? Welcome back. Patrick here, and in this video what I'm going to do is introduce the concept of quartiles, and actually over the next couple of videos we'll be doing a bunch of examples. But before we get into the examples, before we get into the detail, I want to give you a higher level overview of how quartiles work, how we use them, why we use them, etc. So to do a quick little review of what we've been talking about so far, is I've mentioned that whenever you have data, you want to look at a couple of things. Number one, you want to look at its central tendency. And we talked about three measures of central tendency: the mean, mode, and median. But I also mentioned how just looking at the central tendency of data is not enough to give you a full picture of what's going on. You also have to look at its variability. And I showed that through the last video in an example where we had two sets of data, and both sets of data had the same central tendency measures. They both had the same mean, median, mode, but the two sets of data were very different because one varied a lot more than the other. So one had more variability than the other. And in that example, I also introduce a simple measure for variability called the range. And the range is just equal to the largest observation minus the smallest observation. However, I also mentioned that even though the range, it's a nice simple calculation, it also came with some drawbacks. And the biggest drawback, is that it is not resistant to outliers. So, for example, let's say that we had a set of data where we had 6, 7, 8, 9, 10. I'm putting it in order. And then there was also an observation where we had 40. So notice that that is an obvious outlier. Well, notice if that outlier wasn't there, what would the range be? The range would be 4, right? That largest observation minus the smallest. But with that outlier there, look what happens to the range. The range jumps up to 34 because it'd be this 40 minus this 6. So that's an example of where that range is not resistant to outliers. So this outlier really made that range jump when really the bulk of the data is fluctuating between 6 and 10. So this range here doesn't give us an accurate description of this data's variability here. So what we need is a measure that's going to be more resistant to outliers, a measure that's going to allow us to focus more on that bulk of the data and measure that variability, and also a measure that can identify outliers. So then we can potentially maybe keep them out of the data and then get even more accurate measures of central tendency and variability. And a measure that's going to allow that, that's going to be more sophisticated than the range, more resistant to outliers, is breaking up the data into quartiles using something called quartiles, which again I'm going to introduce in this video. And related to quartiles is a visual way to display them called a box whisker plot. So the way that quartiles work is, let's pretend that you have a bunch of data. And let's just represent it with this line over here. And this here, this line, represents the smallest observation. Okay, so remember this is a set of data here. And then this line at the end here represents the largest observation. And then we're going to have a bunch of sets of data in the middle. So pretend that this is in order from smallest to largest. Well, what Quartiles do, is it splits the data up into groups. And the first way to split it up is into two halves. And so what we would do is we would find the median of the data. And the median of the data is actually the same as the second quartile. So what that does is it allows us to split up the data into one half and then a second half, like that. Right? Splits the data up into two halves, and then we have the median, which is the second quartile. And then what we can do is we can take this half here and we could find the median of that set of data. So we would just look at this set of data separately now, and we would find the median of that, and that would be the first quartile. So the first quartile is the median of the first half of the data. And then we would find the median of the second half, which would be the third quartile. So the third quartile is the median of second half of data. Now, one thing I want to mention about quartiles is that quartiles are single values. They're not groups of data. So to be honest, when I first learned this concept, I must have misunderstood it because I thought quartiles are going to be groups of data. So I thought like this first 25% of the data here is going to be the first quartile. This is going to be the second quartile, third quartile, etc. But they're not groups of data, they're just single values. If we have a bunch of data and we find the median of that data, which is going to be the second quartile, that's going to be a single value. And if we find the median of that first half of data, which is going to be the first quartile, that's going to be a single value. Same thing with the third quartile. So thought I would mention that. Also notice that because these quartiles are based on medians, if you remember when we talked about central tendency, we said that the median is more resistant to outliers than the mean. And because these quartiles are based on medians, they're going to be more resistant to outliers. So for example, let's say that we had a set of data with just 3 observations. Let's say we had 5, 6, and 7. Notice that the median of this data is this 6 over here. But let's say that instead of this 7, we had a 50, which would be an outlier if we look at how it compares to this set of data here. But notice that that median isn't changing. That 6 is still that same value. Right? So just an example of how that median is more resistant to outliers, and it's why the quartiles are more resistant to outliers. They're not going to change as much even with the presence of an outlier. So the whiskers are going to change. So this largest observation may be pulled more to the right, or this smallest observation may be more pulled to the left. But these values here, these quartiles, aren't going to change much, if they even change at all. And so splitting up the data like this, what it allows us to do is to look at the bulk of the data, which is going to be around here. And so what we do is that instead of calculating the range between the largest and the smallest observation, we calculate the range between the first quartile and the third quartile. between those measures that are going to be more resistant to the outliers. And this range here between the third and the first quartile, it's called the interquartile range. So there's an actual name for it. And it's basically the difference between the third quartile and the first quartile. Right? And it's going to give us a better idea of the variability of the data than just looking at the difference between the largest and the smallest value. Now, I mentioned that there's a way to visually show this through something called the box whisker plot, and we've actually already started the box whisker plot. It's actually this, but all we do now is we put a box that borders where the sides of that box are going to be at the first quartile and then the third quartile to kind of visually show us what's that interquartile range. And then we also put a line through the median, because there's going to be sets of data where this median line, this second quartile, is going to be closer to the first quartile. Sometimes it'll be closer to the third. Sometimes it'll be more so in the middle, like in this diagram. And so just to visually represent the data a bit better, we put a third line through. So there's 3 lines here: first quartile, second quartile, third quartile, and then that's just a box there. And that right there is a box whisker plot. So the box is here in the middle, and then the whiskers are these lines that are sticking out with that largest observation at the end, and then this smallest observation at the end on the left there. Now, if you remember, when we talked about medians back in the central tendency section, we talked about how there were 2 cases in finding the median based on the number of observations. If there was an odd number of observations, then the median was a single value in the middle. And if there was an even number of observations, then the median would be the average between the 2 middle observations. So because these quartiles are based on medians, there's going to be cases for quartiles as well. And there's actually going to be more than 2 cases because there's multiple medians. So let me better explain. So we're going to have quartiles. And the 2 main cases is if there's going to be an odd number of observations and then the other case is going to be if there's an even number of observations. However, there's also going to be 2 subcases for each of these. So with an odd number of observations, you can have a case where you're going to have odd halves, which I'm going to explain in a sec what that means. And then you can also have even halves. And same thing with an even number of observations. We can have odd halves, or we can have even halves. So let me go through these one by one. So the first case, if we have an odd number of observations and odd halves, an example of this is if the number of observations is 7. So let me show you. 1, 2, 3, 4, 5, 6, 7. 7 observations. Remember, if there's an odd number of observations, which 7 is odd, then the median, the second quartile, is just going to be a single value, the single middle value, which is going to be this one right here. So that's going to be the second quartile. Let's actually just put a 2 there to represent it. And notice that that is a single value. And what I mean by odd halves is notice that the remaining halves, the remaining data on this half and then this second half notice that they have an odd number for each of them as well. Notice there's 3 here and then 3 over there, which is an odd number. And so to find the first quartile, we got to find the median of this data here, which would just be this value right there. It would be a single value because there's an odd number of observations in that group of data that we're looking at. So that would be the first quartile right there. Notice that it is a single value as well. Same thing with this. That's going to be the median of this group of data, which is going to be the third quartile, which is also going to be a single value. Right? So that would be the first case right there. An odd number of observations, 7, with odd halves. So after we get that median, that single median right there, this number of observations is going to be odd, which is 3 in this case. So this case, an odd number of observations and even halves, an example of that would be if there is 9 observations. So watch what happens here. We'll have 1, 2, 3, 4, 5, 6, 7, 8, 9. So the median of this is going to be that middle term, which is going to be this, which is also going to represent that second quartile. And notice now that the remaining data on that first half and the remaining data on that second half, both of those have an even number of observations. So notice we'll have 4 here and then 4 over here. These numbers will always be equal. It's just sometimes they'll be odd, sometimes they'll be even. So now what we got to do to find the first quartile, we have to find the median of this data. And because there's an even number here of observations, 4, it's going to be the average of those middle terms. And so notice that the first quartile in this case here is going to be an average, while this second quartile is still a single value. And then notice the third quartile, it's going to be an average. So in this case, all of them were just single values. In this case, to get that first quartile and that third quartile, you're going to have to take an average because each of those halves now is going to have an even number of observations. So notice how you can have an odd number of observations, but after you take out that median, those remaining halves can sometimes have an odd number of observations or even number of observations. Now, one thing I want to mention that's important, the way that I'm doing it, for an odd number of observations, I am leaving the median out of the halves. So notice when I'm looking at this half of the data, 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 I'm leaving the median out. Notice that the median is not within that circle. And that's how most textbooks, most courses are going to do it. But I have seen cases where they want you to include that median in that first half of the data and then also include that median in the second half of the data. And if that happens, then the first quartile and third quartile in this case isn't going to be a single value anymore because now there's going to be 4 points, so you're going to have to take an average like we did here. Same thing here. There's going to be 4 points, you're going to have to take an average. And then over here, if we include that median in that first half, then there's going to be an odd number of points. It's just going to be a single value. Right? Same thing here. So the median, the second quartile is always going to be a single value. But if we exclude that median, then these two are going to be singles, these two are going to be averages. But if we include that median, then these two are going to be averages, and then these two are going to be singles. But most likely than not, your course, your prof is going to want you to leave that median out when you're looking at those halves of data, but just make sure you follow up with them to see what they actually want. But more than likely, you're going to be leaving it out and you're going to be doing it this way. Okay, now let's move on to an even number of observations. And like this here, an even number of observations is going to have two subcases, odd halves and even halves. So odd halves would be if there is 6 observations, for example. So if there's 6 observations, notice 1, 2, 3, 4, 5, 6. Notice because we have an even number of observations, the median of the entire data, or the second quartile, is always going to be an average of the first 2, or the middle 2 observations. So the second quartile in this case is going to be an average instead of a single point like it was with an odd number of observations. So the second quartile is always going to be an average with an even number of observations. But now the halves of the data, what we're going to do is we're actually going to include that in the first half, we're going to include that first middle observation there. And in the second half, we're going to include that second middle observation. So notice here how the median we left out, right? We left out of these circles. But because the median in this case is based on 2 points, those 2 points we're going to have in the respective halves. Right? So you're going to look at these 3 observations. So notice that the number of observations in each of these halves is odd. So the total number of observations is even at 6, but each half is odd, 3 and 3. And because there's an odd number of observations, when we calculate the median of that group of data, which is going to be the first quartile, notice that it's just going to be a single value. Same thing here. Odd number of observations here, so that median of that group of data, which is going to be the third quartile, single observation. And then that second quartile is going to be an average. And then an even number of halves would be if n is equal to 8. So split this up. If we have 1, 2, 3, 4, 5, 6, 7, 8. Notice that the 2 middle terms, the average of those is going to be the second quartile. So it's going to be an average as well. But notice that in this case, there are 4 sets of observations in that first half of the data, and then 4 observations in that second half of the data. And because it's even and even, right, even halves, that first quartile is going to be an average, and then that third quartile is going to be an average as well. Versus here, they were single because it was odd and odd. Right? So these are the 4 different cases that can come up. And a lot of textbooks, what they'll do is they'll just talk about an odd number of observations and an even number of observations. But lots of them, they don't go into these 2 subcases. So just wanted to mention that just from a higher level of how these quartiles are going to be calculated. And actually what we're going to do is we're going to do 4 examples in the next 4 videos that's going to deal with each of these cases here, where we're going to have to find the quartiles and we're going to have to make the box whisker plot. And then after that, we're also going to talk about other stuff that affects quartiles. We're going to bring back skewness, how skewness affects quartiles, how it affects that box whisker plot, and just a lot more stuff coming up. So again, in the next couple of videos, we're going to do 4 examples for each of these 4 cases.